All right, so y'all go ahead and do the factoring and math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to remove the 4 by multiplying it by the negative 15. So you're going to have x squared plus 4x minus 60. And then whenever you go to factor, you want to make sure to replace your 4 in front of your x's, and we're going to use a positive 10 and a negative 6. And so both sets will reduce by 2. And so we'll have 2x plus 5 and then 2x minus 3. And so that would be your answer for your factoring. For the math knowledge question, we have a function where f of xy is xy minus x minus y. And so they ask us for the value of f of 10, 3. Well, that means that our x is 10 and our y is 3. So we're going to plug it in up here, and we're going to get 10 times 3 minus our x is 10, and then minus 3. So we have 30, and then minus 10 minus 3 is 7, so we have a 7 here. And so 30 minus 7 is 23. So your answer is going to be C. Okay, so we are looking at lesson 74. We're looking at reflections. So hopefully after this lesson, you will understand how reflections work. So a reflection is a type of transformation that reflects every point in a figure over a given line. So every point in your figure gets reflected over a given line. A reflection is an isometry, which means that the pre-image and its reflected image have the same shape and size. So the only thing that changes is the direction of how it's turned or what it looks like, but it has the same shape and size. The pre-image and the image are going to be congruent figures. So if you look here, we have 2 triangles, one over here and one over here, and they are congruent, and every point in one triangle got reflected over a given line. And on this one, the given line is apparently the y-axis, because that's where it is perpendicular. The lines are perpendicular to the y-axis. So that means that the y-axis is our line of symmetry. So we are going to look at this example 1. We want to reflect triangle KLM across the x-axis, and we want to find the vertices of the reflected image, and we also want to write the transformation in mapping notation. So you need to get some graph paper and go ahead and graph that. If y'all would like, you can do multiple ones on a piece of graph paper instead of getting the little graphs at the front. That's up to y'all if you want to go get some graph paper out. All right, so we're going to reflect it across the x-axis. So this is our x-axis here. So to reflect it, we're going to have to be the same distance away and perpendicular. So this K, if we go perpendicular, we're 1 away, and so we come up 1 right here. And so K prime is going to be that point. For L, we are 1, 2, 3, 4. So 1, 2, 3, 4. That would be L prime. And then for M, you're 1 away. So M prime is going to go right there. So we are going to connect our triangle vertices like that. And so that is the reflected image. And now it wants us to write it in the transformation in mapping notation. So here's what you do for mapping notation. We transformed point K, which was at -4, -1. That was the point, 1, 2, 3, 4, and down 1. And it went to K prime, which is at -4, 1. So we started with this point and we transformed it into K prime. For the next one, we'll do L. L was at -2, -4. And when we transformed it, we went to L prime, and it was at -2, +4. For the next one, for M, it was at 2, -1. And so it got transformed to M prime, which is at 2, 1. And so that would be putting it in mapping notation. Looking at example 2, we want to reflect DEF across the line x equals -3. So first what we need to do is to draw the line x equals -3. So 1, 2, 3. That's going to be a vertical line going through the x-axis. Remember, if it's x equals, it has to be going through our x-axis. So we're going to go ahead and draw here. And then it's going to go across. So D is 2 away, and so we're going to come across 2 and make D prime. For F, 1, 2, 3, 4. So 1, 2, 3, 4. F prime is going to be here. And then E is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. I ran off of my little graph on my paper here. But that's going to be the vertices. So now we connect our vertices. Okay, and so there would be our triangle. And it says to identify the vertices of the reflected image. So we're going to put it into mapping notation. So we transformed vertex D, which was at -1, 4, and it went to D prime, which is at -5, 4. Then we transformed E, which was at 3, 3, into E prime, which is at -9, 3. And then we transformed F, which was at 1, 7, into F prime, which is at -7, 7. And so that would be the vertices of the reflected image. Okay, so hopefully that makes sense how you reflect across that line. For the next example, we want to reflect this quadrilateral WXYZ across the line y equals -x. So there are two problems with this one. First, half of you don't remember how to graph y equals -x, even though you have done it for 2.5 years now. You still can't graph that line. This is a slope of a -1, and there's no number here behind the x, so it's going through the origin. So it goes this way, up. I'm going to get the computer to graph it so I can make a straight line. Okay. So now we have our line. And now on this one, if you were able to graph the line, some of y'all don't reflect it correctly, okay? We have to be very careful when we reflect this. The lines that connect x and x prime are going to have to be perpendicular to this line y equals -x, okay? So it has to be perpendicular, so that means that this one right here is going to go this direction, and it's half of a square away, so that means that x prime is going to be right there. So that's x prime. For W, if we go perpendicular, it's going to be right here. And so do you see how it's two squares, but they're diagonals? It's the two diagonals away, so we go 1, 2. And so that is W prime. Okay, for Z, We go 1, 2, 3, and a half. So we go a half, and then 1, 2, 3. And so that would be Z prime. And then for Y, we go 1, 2, 3 and a half. So a half, 1, 2, 3. And so that would be Y prime. Now you may be looking at the figure that you have on your paper and thinking that it does not look like it is reflected. It just doesn't look like it to you. The way that you can check, take your piece of paper and fold it along your line of reflection. And the two pieces should line up. So take your paper, y'all can pause the video while you do this, but take your paper and then fold it and your two figures should line up. Okay, if they don't, then that means that you did not reflect it correctly. So now we identify the vertices of the reflected image. So we start with W. It was at -2, 6. And when we reflected it, we get W prime is at -6, 2. And then we do X, which was at -2, 3. And then when you reflect it, you get X prime is -3, 2. And then we have Y, which was 4, 3. And so Y prime is -3, -4. And then the last one, we have Z, which is at 1, 6. And when you reflect it, you get Z prime is -6, -1. Now I'm going to point this out. You may have noticed it by now, you may not. We reflected it about the line Y equals -X. This is my X value. So -2 would be 2, and that becomes my Y value here. And then for my Y value equals 6, and so that means that my X value is the negative of that, which is -6. So you can check and make sure that they all work like that. They should, because they're reflected across the line Y equals -X. However, that doesn't work if you're using X equals -3. Okay, so don't try it on that one. It doesn't work quite the same way. Okay, look in here. We have a design for a public plaza. Reflect figure A across line M and figure B across line N. And so here is what you're going to end up doing. We're going to draw B first, I guess. Doesn't really matter which one goes first. And then this point's going to come over here. And then this point is going to come here. Okay, and so there would be your B. This point should be maybe a little bit further this direction to make it a right angle, like it is right there. Okay, and then for A, we do the same concept. And so then you connect your vertices. I'm having a really hard time for some reason drawing a straight line on my slate today. And so that would be your A. So hopefully your figures look slightly better than that on your paper, but that would be the concept that you do. You just move one vertex at a time, and then you connect them and you make your figure. So looking at some practice problems, we have a rectangle and we want to reflect it as described in parts A, B, and C. So the first thing you want to do is to draw your rectangle. So we have A at 1, 1, B at 5.51, and then C at 5.5, 3.5, and then D at 1, 3.5. So A, C, and D. Okay, so we're going to reflect this rectangle across the y-axis. And so I'm going to do A in green. So the y-axis is this axis here. So we're just going to go over 1 because D is 1 away. So we'll name it D prime. And then we're going to go over, for C, we're going to go over a half, and then 1, 2, 3, 4, 5. So a half, and then 1, 2, 3, 4, 5. For A, we're going to be right here. So that'll be A prime. And then for B, we're going to end up right here for B prime. And so you draw your rectangle. Okay, so that would be for A. For B, I'll do it in red. We want to reflect it across the line y equals 2. So the line y equals 2 is a horizontal line because it's going through the y-axis at 2. And so this one is actually going to get kind of reflected over itself. So D is 1.5 away. So D is going to be 1.5 away. And so that would be D prime. And C is going to be 1.5 away. So this is going to be C prime here. And then B is 1 away, so it goes here. And then A is 1 away, so it goes right there for A prime. And so you connect your vertices. And that would be your rectangle for C. Now I'm going to erase the red and green part. And I'm going to leave my blue part. If you want to do it on another graph, you would rather do that. For C, I'm going to do it in black. And we're going to reflect it across the line y equals x. So the line y equals x has a slope of 1, and it's going through the origin. Okay? And now, if you notice, A is on the line, so it actually stays. A prime is in the same location. For D, this one is a little bit harder. So the way that you can make it a little easier on yourself, when it gets reflected, y equals x. So for D, our y and our x value get switched. So the point that we're going to make it go to is 3.5, comma 1. So 1, 2, 3.5, and 1. And so that's where our D prime is going to go. Same thing for C prime. Your x and y values get switched. So we're going to go to 3.5 and then 5.5. And so that'd be C prime. And then for B prime, we're going to go to 1, 5.5. I went up too far for C prime. I went up to 6.5 on accident. C prime should be right here. And so you connect your vertices. And so if you want, you can take your paper and fold it across that line of reflection, and that will give you two images that are right on top of each other. And if they aren't, then you've done something wrong, okay? So now we're going to look at another practice problem. We want to reflect it across the line x equals 4. So x equals 4 is this line here. And so we're just going to take it and flip it from this side over to this side. So I'm going to do this point, 1, 2, 3. And this point is 1 away. And then this point is right here. And now before I go too far, I'm going to go ahead and connect some of those pieces. And then we've got this point here. And then we go straight out to 1.5. And then we go straight down to right here. And then we've got this vertical line. And then we go out to 1, 2, 3. So 1, 2, 3. And so there, if you look, it should look symmetric about that line x equals 4. So that would be your figure. Looking at the challenge question, we have a point reflection. It reflects each point of a figure across a common point, and sometimes this point is the origin. So we want to draw a triangle on a coordinate grid and reflect it across the origin. And then how do the coordinates of a point change when it's reflected across the origin? So I'm going to pick a triangle that is a right triangle. You can pick any kind of triangle that you want. It can go in any of the 4 quadrants. It doesn't have to be in the first one. So to reflect it about the origin, this one is 1 away, so we're going to end up here. For this one, to make it perpendicular to it, we've got to make it so that the line of reflection goes through it. So it's got to go this way. So we're going 1, 2, 3, 4, and then over 1. And so we're going to keep going. 1, 2, 3, 4, and over 1. And then I guess I should label my vertices so that I can refer to them. So that would be A prime. That would be B prime. And then for C prime, we went down 1 and over to the left 3. So down 1, over to the left 3. And so that's going to be C prime. And so that would be my reflected triangle. And it says, how do the coordinates of a point change when it's reflected across the origin? Each of the coordinates is reflected by the opposite. So A was 1, 1, and now it's -1, -1. B was 1, 4, and so now B is -1, -4. C was 3, 1, and so now it's -3, -1. So that's what happens whenever you reflect it across the origin. Okay? So that is lesson 74. You need to make sure to do your homework 1 through 30 tonight so that we can go over any questions that you have tomorrow.